Okay, so I hope you're able to hear me fine and everything, John. I'll make this a fairly quick, obviously, run through of how to build a cloud platform for your college, really. So the kind of basic principles. Obviously, you can't cover everything in sort of 40 minutes or so, but some key things that are now available, which just weren't possible 4 or 5 years ago, in terms of building a real platform and a cloud platform for a college. So my name is Carlos Oliveira. I'm the Managing Director of Shaping Cloud. We're Microsoft education partners, and we do a lot of space around Microsoft Cloud Services, Office 365 and Windows Azure especially. So I just want to run through some slides fairly quickly, and then most of this will be an actual demo of the platform and of Azure and the types of things you can do and quickly ramp up. So starting with the real basics, three main types of cloud services that you can procure out there: infrastructure as a service, where it's hosted for you; platform as a service, where you just build upon it; and software as a service, where you're just consuming a service hosted and managed by someone else completely. How that looks in reality to an IT manager, obviously over on the left you've got a current piece of software perhaps that's living on your infrastructure and on your premise, where you manage everything from the networking right the way through to the applications, the data, the middleware, the whole lot. Infrastructure as a service gets you a certain amount sort of handled for you and managed by the vendor with regards to the servers, the storage, the networking, but there's still stuff to manage. It's still just your machine. You still have to manage the applications, the data, and everything else. With platform as a service, you're really just focusing on your applications and your data. So that's the ability to just say, I'm going to build a piece of software. I don't want to have to deal with runtimes or middlewares or operating systems. I just want to push this onto a platform and have it available to me as a piece of software, for example. And then you've got software as a service, where it's 100% managed by the vendor. You pay usually a monthly fee, and in return you get a piece of software. And something like Office 365 kind of fits into that space. Whereas Windows Azure kind of gives you infrastructure as a service piece, it gives you the platform as a service piece, and obviously gives you the ability to develop your own software as a service. So cloud computing patterns, where it makes sense to use the cloud, and it's not always everyone should be on the cloud and every single application should be on the cloud, but there's certain patterns to look for that if any of these fit, definitely make it worthwhile to look towards cloud computing. The key one is on and off, and obviously colleges and all education institutions have some amount of this. You have, when you're out of term time, do these services, do these applications need to be running? Do they need to be on 24/7? If they don't, cloud computing gives you that ability to just say, actually, let's stop that here. I stopped paying for it, and I'm going to start paying for it again when I need it. Growing fast, so possibly less relevant in the education space, but certainly in terms of startups or something where you might deploy an application or a piece of software or something that might go viral, where it's gone from very few sort of page requests up to millions. Then again, the cloud's perfect for that because you can just scale with it. Unpredictable bursting, so if you're going to get a strange peaks in demand, and you need something that's going to be able to scale with it and then scale back down without you having to run around the houses and reconfigure new kit or deploy new infrastructure, then again, the cloud's perfect for that. And another one that probably fits quite well into education is predictable bursting. So around exam time, exam results time, everything's going to come under a bit more pressure. Your infrastructure might be strained, so you can burst it up when needed and then bring it back down again when you don't. So there's a couple of things there that I do think fit really well into the college space, which is why I do think that the Windows Azure really can bring some benefits. So Azure is essentially a set of services to enable you to build, host, and scale applications. Obviously, in Microsoft built and hosted data centers. It's extremely large, and from an end user point of view, you can kind of think of it as infinite scalability. Obviously, at the back end, they're real servers. There's real people managing those servers. But from an average end user perspective, there's really no limit to what you can use and how much of it you can use. It's global, so I think there's about 27 data centers now around the world. I know they're planning to build a few more. So you've got complete global coverage. Depends. We do quite a lot within the university space, where there's more of a trend towards having foreign-based campuses, and so certainly having that global footprint for them and being able to connect and create that virtual network is quite powerful. So I'm going to talk through sort of some of the key aspects of the Azure sort of offering, and then actually go and demo them and show you how you might use them in reality. So starting with the simple stuff, the infrastructure as a service, it has virtual machines. So you can spin up a virtual machine. It has Windows Server, it has Linux, and you can pretty much deploy any kind of version of that you want. So if you've got your own images and your own standard builds, you just have to go through a process, package those up, and you can spin up base installs very, very quickly. It's very flexible. Again, you have scalability, and you've got complete control over creating VPNs and virtual networks. So your infrastructure becomes one infrastructure, whether it's on-premise or cloud. You can have that one view of the world. Websites are a relatively new feature of Windows Azure. Probably in the last 12 months, they've really been pushed. And these are what they say, they're very simple websites managed and hosted in Azure. So all you do is say, I want a new website. It has a ton of pre-installed sort of CMS packages, blog packages, e-commerce packages. You can pick one, deploy a website, and you're up and running, and that's it. There's nothing to deploy. You don't have to log on to a server. You don't have to configure IaaS. So for really quick, easy, when you need a web endpoint, you need some kind of web presence, it's a great and very cheap way of doing that. And again, it's open technology. Windows Azure is not .NET. It is not locked down to Microsoft technologies. You can deploy any technology that you want onto that. Cloud services are kind of where Azure started, if you like, and it's very much in that platform as a service space. So this gives you the ability to build a piece of software, develop it locally, work in Visual Studio or whatever other tool you want to work in, and then deploy that up to the cloud. And it has a nice sort of architecture of splitting out web roles and what are called worker roles. So a web role would just be a web endpoint, and pretty much that these days is a website. But the worker role is just a nice sort of background process for long-running threads, for doing complicated calculations or things like that. We did a project with the University of Sheffield around calculating carbon emissions in the supply chain, and that fitted really well into the sort of cloud services model, where the website was there. And then in the back end, we had a much more powerful worker role that could do these calculations a lot quicker and bring them back. So it separates out your architecture and gives you scalability. Mobile services, again, relatively new to Azure, and it's quite comprehensive what they've built. So it's a whole suite, and again, I will demo this, of building a back-end mobile services. So essentially a really simple REST API mobile service that you can use as obviously a mobile app if you want to develop a mobile app, but even within your web applications you can use these services as a very, very quick way to build simple applications. There's SDKs, so you can build Windows apps, iOS apps, Android apps, or just straight HTML and JavaScript apps. And it's fully hooked up into push notifications, so you can have Apple push notifications, Google, Microsoft. And again, we'll come onto it in the demo, but there's obviously a lot that you can do with that as a college or an institution when it comes to communication via students and parents and teachers, if need be. So you can think of Azure, you've got those sort of key services that we'll demo, but around that there's all of these application building blocks. And you can think of this a little bit like Lego, right? You can use these building blocks to kind of configure an infrastructure and a platform that does whatever you need it to do. It's very, very flexible, and the way they kind of fit together is really nice and intuitive. So, you know, we've got things like databases and storage, traffic managers, content delivery networks. There's built-in identity, so you can hook up Active Directory federation services very easily. There's a whole media services, so if you're doing content encoding, certainly, you know, within a college, if you've got certain courses, media courses where students are filming lots of video, and the process of getting that encoded and delivered is obviously quite compute intensive. There's a whole media services part of Azure that allows you to do that very easily. Allows you to have that video stream out. You can even put paywalls behind it. You know, lots of really nice built-in functionality from the get-go. There's a whole big data sort of application block that's built around Hadoop. So again, data analysis and running big data scenarios and really crunching the information that you hold. That's all possible as well within Azure. There's far too much for me to cover in this, so, you know, I have to kind of pick and choose the key parts, but I kind of wanted to raise this as things that you can look at. So SQL databases, I'm not going to spend a lot of time on this slide. You can build a SQL database and do all the things you could do with a SQL database that you have in your current on-premise environment. Blob storage is a much cheaper, more flexible way of storing stuff in the cloud. So you can store, it's very good for storing documents, files, that kind of stuff. Things that wouldn't sit in a database, or you wouldn't necessarily want to have sat in your database, you know, large files and things like that, images. You can use this blob storage as a kind of very cheap storage mechanism for putting all of that stuff in there. Cache is built in, so when you create any of these Azure, say, cloud services or virtual machines, you can dedicate a certain amount of that in memory to caching. So create highly available, and it dynamically will grow and shrink the cache as you go through. So for you know, very high performance type applications and scenarios where performance is crucial, this caching block comes in very, very useful. Identity, like I mentioned, it fully integrates into your on-premise identity and Active Directory. A new feature that's just been launched in sort of the last couple of weeks is now multi-factor authentication. So above and beyond the normal sort of ADFS security that you can put around, say, a website, you can now have multi-factor where they log in and then they will get a text message with a code, and they have to put that code in. So for very secure, you know, if you're thinking of confidential information or anything like that that you're concerned about, multi-factor authentication is a great option that's available now. You know, Active Directory is pretty much the standard, so it hooks perfectly into that. Service Bus is very powerful and is used for building large sort of enterprise scale messaging systems. So relaying messages, it's persistent, the messages don't disappear. And you can obviously again build a very flexible and kind of not too connected architecture, you know, loosely connected architecture that will scale to massive numbers. Few others, HD Insight for big data. You've got media services that I mentioned, and you've got BizTalk services, again a fairly new addition to Azure, and they just keep adding stuff. So, you know, there isn't an organization in the world that would need all of this stuff, but there's plenty who need bits and pieces of it, and that's what it lets you do, is take the bits that really interest you and are really going to add value. Okay, that's enough of the slides, and that's more or less all we're going to do on those. So I really wanted to now show you this stuff and show you, in the next kind of, well, we'll say 25 minutes, just how much you can actually do with Windows Azure and with the infrastructure that you have available. So I'll make this large, so hopefully everyone can see it. This is the Windows Azure portal, and here are kind of most of the things I've mentioned in the slides: websites, virtual machines, mobile services, everything else, and everything is accessed from here. It's the one thing that Microsoft have done really, really well with Azure, is make it unified and make it simple for people to use and understand. So let me just bring my notes up on the other screen. So what I wanted to sort of start with is the very simple stuff, and that's a virtual machine. So here's a list of current virtual machines that I've got. I want to go and create a new one. I come out down here, pick compute virtual machine, and I can quickly create a VM which will have some defaults on it, or I can pick from a gallery. So in the gallery you'll see all the virtual images that are available. So Windows Server 2012 is on there, the R2 previews on there. So again, if you're thinking of a test environment or getting a bit of a sneak peek at some of the latest versions of Microsoft technology, they tend to come on here as images. We've got 2008 if we need that. We've got SharePoint, a whole heap of SQL Server images, again including the new 2014 evaluations, right the way back to 2008 if we need it. We've got BizTalk, we've got virtual machines now with Java, a whole heap of Oracle VMs which were just added I think last week. So Microsoft have done the deal with Oracle, so you can have all of the Oracle WebLogic database stuff on there. And then you get into your Linux environments and everything else. So there's tons there already built in. And then you've got, like I said, the option to have your own images, your own disks, and use those instead. So here are some of the disks we've created in the past. If I then wanted to spin up another IPython instance, for example, I could just click it here and it will do it for me. So let's go simple. We'll go with Windows Server, say, let's do 2012 R2. Give it a name, so we'll call it Cloud College. A small size, so again you can scale up or out depending on what you need, but you've got right the way up to 8 cores and 56 gig of memory, so you've got some very powerful VMs now available if needed. We'll just use a small one, put some admin credentials in, continue. So we're going to create a new cloud service, which is essentially where the disk gets uploaded to. I pick a subscription, so I'll pick my MSDN subscription. I pick where I want to deploy it to. So again, this global footprint. So if I wanted to put it in the US, if I wanted to put it in Asia, obviously we'll do Europe. Storage account and availability set, which is kind of where you can group stuff together. So if you were building a full cloud platform, you'd create an availability set and make sure that all of your Azure instances were in that availability set, and that guarantees that they basically are close to each other, and you'll get absolute maximum performance by them being in the same availability set. I won't select one here because it's obviously not relevant. I can open up endpoints. By default, it will open up a remote desktop endpoint and PowerShell. But obviously, if this was going to be a web server, I might go in and just enable HTTP, and that will allow me to have HTTP and IaaS running on it, and anything else that I wanted. So once I'm happy with that, I hit go, and you'll see it just start spinning. So it will start to create the virtual machine. It should take 3-4 minutes max, really, to do that. While it's creating that virtual machine, we can just talk a little bit about how you would then integrate that virtual machine. So it's great, you've got a virtual machine, it runs in Azure, but you want to connect it to your on-premise. That's when you can come down to networks and actually create a new virtual network. So we've got one set up here, but we're going to create a new one. So I'm going to create a new virtual network. I want to do a custom create. Again, call it Cloud College Network. Affinity group. So this is again where you create that affinity group and you'd group everything together. We'll continue with that. So it starts to build up my network. So here I can put any DNS servers that I want, and I can configure point-to-site connectivity, and I can also configure site-to-site connectivity. So I can set up all, whatever suits this application scenario, whatever I need to kind of create, I can do this from here. It gives me a very simple network diagram down the bottom of what I'm doing. Allocate an address space to what my network's going to be, sort of standard infrastructure stuff. Give it a name, give it a VPN, so the IP of your router. Once you've done this, obviously you then go on your router, make the necessary configurations on your router, but that's about it. You're done. You then have full site to site. It just becomes part of your network, and it's very, very simple to do. So you won't go through and actually click that, but that's sort of the process. We then want authentication, and we want people to be able to log onto it using their Active Directory credentials. You can come in here and create a new Active Directory and hook it up to your on-premise AD. So there's a little bit more to it than obviously just a few clicks here. There is some setup that needs to be had, but it's pretty straightforward, and once it's up, it's up. And here's the multi-factor piece that I spoke about, where you can create new multi-factor authentication, and you can different licensing costs. You can either do it per user or per authentication, depending on what best suits your scenario. And you'd set it up, you'd hook it up to a Active Directory, and that is it. And from that point on, users will have this multi-factor process where they need to have a valid phone number added, and they will get text messages in order to log on to a service. So a great way to secure any site that you deploy out there. So my VM is still spinning away. Step through. Okay. While that is still spinning, I'll just skip ahead and create a website. So the website, the way it works, very similar to the virtual machines. I create a new website. Again, there's a gallery. And let's say we want to create maybe a blogging framework for a college class or project or some collaborative piece of work that people are working on together. And we just need a really simple site that people can go contribute to, put findings up on. So WordPress fits perfectly for that. Again, we just give it a name. We want to use a new MySQL database, so it will create the database for us. I need to pick a subscription. I'll pick this one, and I need to pick a region. So we'll go with West Europe on this one. Hit go. It will give me the credentials to my new SQL database. Happy enough with that. Agree to ClearDB, who actually provide the MySQL infrastructure. Hit go, and it's going to start deploying WordPress. So at this point, it's spinning up the WordPress site itself. It's also spinning up the new MySQL database. And websites per subscription, you get 10 free websites. So you'll see as it's creating it here, it's on the free mode. So you can have up to 10 free websites. The only time you'd want to pay for websites is if you needed your own vanity domain. So if it had to be, yourcollege.co.uk, then you'd move it onto a shared instance. But they're very cheap and very flexible. So the website's now been created. I can hit OK, come into here, and you'll see I've got a whole dashboard where it will show me all of my endpoints to my website. I can FTP onto it if I need to deploy new code to it. I can actually set up deployment from source control. So if I want to develop my own WordPress site, I can deploy instantly from my source control. And then I've got a URL, so cloudcollege.azurewebsites.net. If I click, I've now got a WordPress site. So it's there, I just have to follow the steps, and there's a WordPress site set up in, less than 5 minutes. So very simple, very powerful, and saves so much time when you consider what it normally takes to set up a web server, configure IaaS endpoints, make sure everything else is correct and in place. And then the other thing that you have is this ability to auto scale. So, if this website goes viral or whatever else, you can set up an auto scaling system that will automatically scale the site to meet demand. And obviously you can limit it to a certain amount of machines to not get carried away on your spend, but very powerful, very flexible, and very straightforward. While that was happening, the virtual machine has now been created. So again, I can click onto my virtual machines. Here's my cloud college machine. It's running. I've got a DNS name. I've got an endpoint. And if I go to my dashboard, I can connect to it. So I can hit connect from here. It's going to download an RDP file. Open that up. Put the credentials in that I put in at the start. And here we are, we're on a Windows Server 2012 R2 machine. It's going to go through all of the usual initial configuration, but that's it. I've now got a virtual machine. I can deploy what I want to it. I can install anything I like. I can connect that up to my on-premise environment. Again, you're talking a matter of minutes to get this thing set up and running, and it just saves so much time. And again, the big thing with this is you pay for what you use. So out of term time, when this doesn't need to be used, you just stop the service and you stop paying. So, very straightforward. I just need to get out of here. Get that down. So that's your VM. I'm just going to disconnect from it now. But like I said, at any point, if I want to, I can shut down the machine and I'm going to stop paying for it, which is a great way to save quite a lot of money. So we've set up a website, we've set up a virtual machine. Now I wanted to deploy perhaps our own sort of custom software as a service. So I wanted to deploy a cloud service. So you can do that directly from Visual Studio. So again, if you've got students who are running projects and they need test environments, and you might have servers set up where students deploy their code to, students run their code, all of that can be sort of moved to Azure and the cloud platform. So within Visual Studio, I can go and I can create a new Windows Azure cloud service, hit OK. It will give me the standard kind of options that you get. So I want to create an MVC4 web role, just a standard internet application, which will by default give me authentication and a login system and a few other basic pages, just as a sort of demo site really. So Visual Studio will go away and spin up the project. Okay, so it's created now an MVC project. I'm not going to go into coding details. I don't know what the technical scope is of people on the call, but here's a pretty straightforward, simple web application. I can actually debug it locally, so I can deploy the application and just make sure that I'm happy with it. So we'll do that first, just to make sure. So you'll see that locally you've got a whole Azure SDK, and so what it does now is, yes, it kicks off and debugs the application, but it debugs it within a Windows Azure emulator. So I know that option in the action in Azure. So you don't build a standard web application and just debug it in IIS. It actually, the SDK builds this for you and puts it into the emulator for you. So that's just spinning up. You can see just a local endpoint on my machine. Obviously takes a while on first run as it compiles everything in debug mode. Come on, code. This is where you just have to pray to the demo gods. Here we go. Okay, it's come to us. So here's the standard homepage, .NET. I've got login and registration features and a couple of standard pages. You know, you can obviously build on top of this and build to your heart's content until you're happy with it. And then once you are happy with it, you can stop the debugging up here. Right click on the project and hit publish to Windows Azure. So directly from Visual Studio, I don't have to go into the portal for this. I don't have to do anything. I just can hit publish directly from within Visual Studio. So put it into a cloud service, into production, create a new cloud service, Cloud College again. Pick a region, so you know, sort you as you would in the portal. I can enable remote desktops because obviously in the backend it's just spinning up VMs. We won't need that, so we just hit publish, and that's going to kick off, build the solution, package it up, push it up to Windows Azure, spin up the virtual machines, deploy the package to them, configure IaaS, and then give me all that stuff that manually you'd have had to done previously with deployed code. It's now just going to start deploying it for us. So we'll let that spin. That will take, you know, a little bit of time because obviously there's quite a lot for it to do, but it started kicking off that deployment. So one other thing to show quickly before we move on to mobile services is databases. Again, fundamental part of any infrastructure is your databases. And again, you can have your servers and then you can have multiple databases on those servers. So we're going to create a new database. It's going to be SQL. We're going to do quick create. We're going to create a new SQL database, Cloud College DB. Pick a subscription. Again, give it a login name. Hit create SQL database. Now, I am by my nature a developer, and I've worked in various places and various organizations, and I know that getting new SQL databases from DBAs in large organizations and large enterprises takes quite a lot of time, depending on their mood and how much coffee they've had. So here, that's done. I've now created a database server, and that was less than 30 seconds. So I've now got a database available here. So I can, obviously I want to connect to that database, so I can come to my dashboard. Let's create a new SQL database now within. So we want to create a new database, so we'll call this one students. It's a web database, 1 gig. Again, pick a few things, pick a subscription, pick the server. So that's the server we've just created, which we put in Southeast Asia. And that's, so now I've got a database server and I've got a database within my server. So if I come into here, page is students, dashboard. Now I want to connect to my server, so I can use, standard SQL Server Management Studio to connect. I put in the server name here, I put in my credentials, but it should fail. I'm hoping it will fail. Okay, because by default, Azure in any database you create is whitelisted. So it will only allow, if I go to manage allow IP addresses, it will only allow other Windows Azure services to connect to it. So by default, no one else from the internet or from the web is able to actually get to your database without being specifically whitelisted. So in my case, I can come in, it shows me my current IP address, I can add it to the allowed address list, hit save, let that spin for a second. Okay, now when I hit connect, hopefully I get in and I've got my database and I can do whatever I would normally do within SQL Management Studio. So again, such sort of speed and ease of use that just previously would have been very, very difficult to achieve. And there I've got my two databases that I've created. Just check on our cloud service, that's still deploying. Okay, so we're going to jump back out and talk very quickly about mobile services. So again, like I said before, the way they've unified everything and made everything kind of standard, it's no surprise that to create a new mobile service, you come to mobile services, you hit the new button down here, hit create, give it a name, create a free database. So again, if you're just wanting to test something really great for prototyping and throwing something together quite quickly, free 20 meg database, pick a subscription, pick a region. Not that one, let's put it on this one. And hit next. Again, we've got a server, so we can use our Cloud College DB that we created just now. So now it's going to spin up a new mobile service. It shouldn't take too long. So to explain a little bit, you get, like I said, it's essentially a REST API. So it's a REST API connected up to a database. And it just means that you can create very, very lightweight, easy mobile applications, either a custom mobile application for your college, a simple web application that users can just navigate to on mobile phones or on tablet devices, and interact with your data in whatever way you want them to. But because it's a REST API, because it's just JSON data, it's very lightweight, and messaging coming back and forward is very quick. So it's hugely scalable, and is fully hooked up into, like I said, push notifications. So you can send, for instance, the college is going to be shut today because of snow. You can just push a notification out to all of your users who have the specific college app, for example. So it's created a mobile service. That's great. At the moment, there's nothing in it, so we want some data. So by coming to data, it's obviously telling me I've got no tables. So if we want to add a table, let's call it students. Again, it's got authentication and security built in. Obviously, I'm just demoing this very quickly, so I'm just going to give permission to everyone. It means I don't need to put in the application key on my requests. I can just hit the endpoint. Obviously, in real world, you wouldn't necessarily do this. Hit OK. It's going to create a new table in my database called students. Okay, so that's there. That's great. If I navigate to this mobile service URL, you'll see mobile service is up and running. So, okay, we know it's there. So if it's up and running, then in theory, I should be able to call the URL /students and get a response. Okay, so I've had a response, but the response is just an empty JSON string, because obviously there is nothing in that table at the moment. There are no students. Now, what's really sort of neat and powerful about this is I don't now have to go into SQL, go and define a table structure for my students, go and do all of that. You know, there's a place for relational databases, and there's a place for that sort of architecture. But when you're talking about sort of rapid application development or quickly putting proof of concepts together, this is fantastic. So I can go and say, I'm going to post, again up at the top, to tables/students. I'm going to post some data, and it's just a name, it's me, and my age. I hit send. I've now had a response back from the mobile service, coming back with my same message, but I've now got an ID attached to it. So ID 1 for Carlos. I want to add another one for Tom, 28. Hit send. It's come back with Tom, ID number 2. If I jump into the portal itself and come to my data section, you'll see I've got students, and it shows me that I've got 2 records in that table, and I can come in here. It's got name, it's got age. Because it's this sort of a concept of almost a NoSQL database, if you like to call it that, from the perspective of the application, it's very flexible. There's no defined schema. I can add new columns to this table. I can change columns, and I can update data without going through any sort of rigid processes. So if I come back to, say, the Postman interface, you know, I have to sort of maybe come clean and say, well, actually, I'm not 25. I'm actually 34. So I can send out a patch request to tables/students/1, which was the ID I was allocated. Hit send, and there you go. It's updated my record, so now it's got my age correctly in that database. I might leave the student organization, or I might leave the college. Again, it's same URL, so it's to me, my record, but I'm sending a delete request. You'll see over here I'm using a delete request. So if I hit send on that, I'm now no longer there. And if I come into, keep doing that, if I come into here and refresh this table, you'll see only Tom exists in there. So, I mean, just phenomenal in terms of what you can do with that kind of infrastructure. You'll see behind the table, there's a scripting function, which is all written in Node.js, and I can put custom script code in here for different operations. So if I want that every time I update a record, it potentially sends out an email or runs some kind of custom code, I can put that directly into here very quickly, very easily. Like I said, this doesn't replace sort of enterprise architecture fundamentals and some of the things you would do on different types of systems, but for what it does it phenomenally well. You can have custom APIs, so if you want to create an API that's not actually tied to a database, you can do that from here. There's scheduling functionality, so if you want to send out regular notifications or updates via the mobile service, you can do that. And you can obviously here connect up all of the push notification servers to Apple, to Google, and to Windows. It's got identity features built in. If you want users to be able to log on with Facebook or Twitter or Google, you can do that from here. And as with everything in Windows Azure, it's got this ability to scale to whatever size you want it to be. So that's mobile services very, very quickly. Hopefully, if we go back to Visual Studio, you'll see my app has deployed. I've now got a website URL, cloudcolleges.cloudapp.net. And if I click on that, it fires up over here in Internet Explorer. Okay, so that's come up. So that application that was just running on my desktop is now running in a Windows Azure data center, and I've literally done nothing, right? I hit publish and everything was done for me. My pages are there. I've got my login ability. I can still register. It looks exactly as it did on my desktop. So that is a very powerful way to build and deploy applications. And certainly when you're talking about computing courses and lots of students who are wanting to deploy stuff, making it this simple, allowing them to just focus on the code or on the problem they're trying to solve is really quite powerful. So that is more or less it from my whistle stop tour of Azure and how you can use Azure to kind of build a cloud platform. Just bring up the last couple of slides I have. Well, swap that. To grind to a bit of a halt here. Okay. That's so. Obviously, it's great for things that need scalability and availability and fault tolerance. Perfect for websites, complications, web APIs, even social gaming, which isn't obviously something we've touched. You know, global data footprint, 99.95% monthly SLA, and obviously only pay for what you use. Flexible and open. You can deploy Windows, you can deploy Linux, you can deploy Java, you can deploy all sorts of stuff on it. And you've got these managed building blocks that allow you to configure and build stuff in a really nice way and really build a platform bespoke for your needs. A few useful sites. There's obviously Three, who's sort of product leader on this and is just anything about Azure. It goes on Scott's blog first, any new releases. The user group, so Shaping Cloud and myself, we run the UK Windows Azure user group up in Manchester. There's also one in London. So if you're interested in maybe coming along to one of those events, you can go on the website ukwalk.net, and then there's obviously tons of Azure resources on the Azure portal. Some really good documentation, some really good hands-on labs and walkthroughs of how you do some of the things that I've obviously shown you today. So that is it from me. Thank you very much for taking the time to kind of join us during your lunch break. I hope that was useful. We've got a little bit of time, so if anyone does have any questions, and either chat directly or maybe put them onto the link messaging section, and I'm happy to answer them. Basically, okay, if there's no questions, then I'm going to let you guys get back to your days. Thank you for taking the time out to join the meeting. And as and when you do have any further questions, please just either let myself or Rob know, who was on the original emails in terms of the invite.